Hey guys, so recently we started talking about free body diagrams. And remember, that is just a representation that's used to show the forces acting upon an object. I wanted to do 3 quick examples with you guys just to help refresh our memories on that. So to do that, I'm going to go ahead and I'm going to stop my video on this one and share the screen on my next one so we have a thing on that. This is going to be found on your notes as well if you want to refer to that. But the one I want to look at, there's 3. The first one I want to talk about says a book sitting on a table. Now, please remember that the book sitting on the table, when we talk about that, there are automatically going to be 2 forces acting upon that book. Remember, there's the force of gravity that's going to be pulling it down, but there's also what we call the normal force. So anytime you have an object that is sitting on another object, we refer to that as the normal force. Now to draw that, we would need to do the following. I'm going to draw a box right here that represents my object, and then gravity is going to be pulling it down. So we need to go there, and we're going to label that as F-grav for gravity. Now, because the object is stationary, it's not moving, it's the constant, the force of gravity and the normal force, they need to be equal length of arrows, showing that those are equal forces, and that's why it's not moving. So it would look something like this, and we would want to label this as F of norm, and that would show us that one. The second one that I want to look at real quick says a skydiver, it's falling at a constant speed and it's falling from the sky. So you have to think, remember, the first thing we're going to do is draw our representation of that skydiver right there, our box. And we know that gravity is pulling that skydiver down. So you have to label that F-grav. And then there's no norm force acting on this one because the skydiver is not on anything. But there is a friction force that's pulling back on him or pulling back on him, and that's going to be air resistance. And so because it's falling at a constant speed, we need to make sure that our force of gravity and our force of air resistance or friction, whichever you want to call it, are the same length. So we've got F-grav. So right up here, I want to make my F of air resistance the same length as that, and that represents that it's falling at a constant speed. The next one, just real quick, that we're going to look at says a jet accelerates on a runway, but it doesn't lift off the ground yet. So that means it's just going straight on that runway. I'm going to go ahead and draw my jet to represent that. And we know that we have the force of gravity acting upon that automatically. Now it's not lifting up off the runway. So what is that going to tell us about that norm force? Because the runway, as the object it's on, if it's not lifting up, that means that these two should be equal in length. Your F-grav and your F-norm should be equal in length. And that tells us that it's not going up. Now, if it were lifting up in the air, then our top force would be longer, representing a larger force pulling us up. But the other thing it says it's accelerating on a runway. So that means it's accelerating in one direction. And that's often going to be called thrust. I'm just going to put it accelerating right. And to show that it's accelerating, this arrow must be longer than the opposing arrow or than the friction arrow. So I'm going to come right on this side, and I'm going to show this as friction is also acting upon there. But it's not as strong, which is allowing it to go or accelerate in the rightward direction. Hopefully this helps with those 3, and we'll have to go from there.